This is all your.
Yeah, I need the number is here. It was here. Where did it go? Not the folder. The okay.
Desktop.
No temp.
This wait.
This PC
Okay.
and temp.
And the temp. There is no temp folder.
It should be there. Let me see. Because there is where I saved.
Okay.
Here. Good.
Yeah, go ahead and then open your software. I will give a brief overall introduction of the program, and then you will do a very specific presentation.
Yep.
How to do it. That's how we move on. Yeah. So make it full screen.
No, it doesn't advise you to make it.
Okay.
If you make it full screen, it's gonna cry. See?
Oh, okay. Okay. You can make whatever you feel comfortable with.
Yeah.
Still have 3 more minutes.
So I can mute myself here, right?
No, you're already, it's already on.
Yeah, if I want to mute, then it is here.
Yeah.
Okay.
Yeah. I think for the beginning, please open the camera, and then after that, if you think it makes your presentation better, so that you can turn off. But for the beginning, we need to turn on the camera to at least see who are the presentees.
It is on, but where is the picture?
Oh,
It's. So,
Yes.
yeah.
Yep.
Yes.
hey, Basil, you there? Hey, Basil, can you hear us?
Yeah, I can hear you. Hello.
Turn the volume.
On your screen, can you see Solomon on one side and you see like the
presentation
Screen on the other side,
on the
yeah.
other side?
Yeah.
Okay, just making sure.
So the volume is 100 full, but still we could not hear clearly. So hold on. There is a volume key here.
He's getting crazy.
Oh, okay, there. That's fine. Okay.
I did have
It's still not.
Hey, Ancor, can you hear us?
Yep, I can hear you guys.
Okay,
Right.
good. So
We have 2 customers so far.
only 2 people.
So far, Amber's there, but she's a admin. She just records
Yeah,
it.
I
She's
think
recording.
let's wait a couple of more, at least two more minutes. So that
David's there now.
Dave is there.
Hey, David, can you hear us?
Yeah, I can hear you.
All right.
Okay.
How's married life?
He got married?
Yeah,
Oh, okay.
that's why he was.
Congratulations, David.
All right. HydroCAD, let's go.
Yeah. So we will give at least a couple of more minutes. Is 12:01. I will start 12:03. 2 minutes at least to give a chance for people to join.
Look what I have.
Oh.
You know. Okay, I can't take it back. I can't take it back.
Oh,
I'm gonna- Yeah,
Okay.
that's my input.
Okay, 12:03. Yeah. Let's get it started. Welcome. Good afternoon. Welcome everybody. Today we are going to do a launch and learn regarding HydroCAD software, which is a very strong tool for water resources. Solomon and myself have at least more than 6 year experience using this in the previous other projects, and we really found this HydroCAD a very beneficial because I like to speak a little bit overall what HydroCAD does. HydroCAD does water resources analysis independently. We don't need any other software to get a data from. For example, for the TR20, we need a TR55 to get a carb number and time of concentration so that we can put in the TR20. That was our software before HydroCAD came into. So they need to go hand in hand, TR20 and TR55. But HydroCAD creates time of concentration, carb numbers itself, and does not need help from other software. That's why it is a very powerful tool, and it can do a lot of water resources designs compared to TR20. For example, to do a flow filter in the TR20, there is a long process. If we need to bypass something or separate flow, maintain the base flow. But here, it's a one click, very easy. So that's why we think this software is important, and I requested management and we have it now. I like Solomon to show in and out of the software, and definitely after he shows that you guys will have a question, feel free to ask either Solomon or myself. So thank you, Solomon. Go ahead.
All right, welcome everybody. So I'm gonna share what I know about HydroCAD today. The first thing, of course, is gonna be opening the program. So I have it here on my desktop. Double click.
This will be like a informal workshop rather than a PowerPoint presentation. Solomon will really show an example project how to create a HydroCAD.
All right, here we have opened HydroCAD. So we have here 4 nodes to be selected when you're creating the program. I mean the file or some the routing. So the first thing is gonna be we're gonna be open the file. I know I have some files here prepared, but for now, I'm gonna create a new file so that everybody knows how to create a new file. So I'm gonna call it test here and open. So it's gonna ask me that it doesn't exist or if I wanna create it. So I'm gonna say yes. So I have a new model called tests here. So now from now, I'm gonna maybe check our setting here. You can change whatever setting you have here. You can set up the rainfall, the time span, how do you create your report, a unit hydrograph, what kind of hydrograph you're gonna use, and some other settings, which I'm gonna touch if time allows. So the first thing we need to do is to create a subcatchment. So what you need to do is just drag, and here you have a subcatchment to start with, and of course it is empty now. So if I right click and now the report is not gonna show me anything because I don't have anything input here. So no runoff, no time of concentration. So what I need to do is I'm gonna edit it. Oh, by the way, if you wanna rename it, you can rename it here. You can remember it. Let's say it is POI 1. So it's gonna be renamed as POI. And here also you can change the text which is gonna be seen here. So by editing that subcatchment, you're gonna have an option to put some area, time of concentration, and some notes for you to remember what you did. So for the area, it is like the same as like a simple TR55. So you're gonna put the area here and the curve number, and of course the weighted will be shown here. So I'm gonna start with, let's say, open space. Here you have the TR55 version of land use. So I'm gonna say, let's say I have B soil and grass 75%. So I'm gonna double click on that. I have it here. And then I'm gonna put some area, let's say 3.5 acre. And here you see the total area and the weighted curve number. So I'm gonna add on another, so for example, parked area, sea soil, let's say 1.2 acres. So it is now 70, the weighted curve number. And then let's put some wood area somewhere here. I'm gonna add wood in good condition, and it's gonna be B soil for this example, and the area will be 0.5 acres. So now I have areas, the curve numbers, and here it calculates for me the weighted curve number. So I'm gonna say okay. So if I now want to see the report for that, let me see. It is asking me for the rainfall. So again, I'm going to edit the TC path. Again, the TC path, you have options either to put directly or to calculate it based on how we did it in other TR55. So I'm gonna start with sheet flow here. For this example, if you based on what surface you choose, it's gonna bring or it's gonna give you the Manning's coefficient. So the flow length is gonna be 100, and land slope feet per feet is gonna be, let's say it is 2%, and then you have to put, of course, the 2 year like we did it in our Excel sheet, also a spreadsheet, the 2 year runoff, the 2 year rainfall depths. So it's gonna ask me, of course. So I'm gonna say, let me cancel it. I'm gonna go back to the rainfall at the setting here, calculations, and then rainfall here. Here you have a lot of options to choose from. So what we use here nowadays is a NOAA 24-hour, and then we're gonna choose whatever distribution curve we want. I think we are using C curve, right? And then you're gonna put whatever depths you want to be included in your model. So for me, I'm gonna use 1 year. Oh, let me see. Here I have some example. For 1 year, let's say it is 2.5 inch. And then to save it, you're gonna type here the name, you call it 1 year, and save it. Whatever depths you want. And then if you want 10 year, let's say we have 4.6 inch, and then here you're gonna name it again, 10 year, and of course you have to save it. Now we have 2 rainfall depths, and based on a NOAA 24C curve. So if I click on one, it is 2.5, 1 year, and then
So,
yes,
so this OSC, it doesn't directly,
you can import it. You can
yeah,
import, yeah.
okay.
You can import, but
Yeah.
for simplicity, I'm just typing here whatever,
Yeah,
to make it shorter here.
okay.
Yeah.
But you can import. There is somewhere imports here. You see, import storm event. You
Yeah.
can use that too.
Yep.
So to import, you need some sort of, like an Excel sheet or what kind of?
I don't think so. I think you can look up from some other, yeah. Or if you have another project also, you can
Yeah,
which you used already, you can import it from that project also.
because your NOAA rainfall intensity vary.
Yeah,
Yes.
it is county by county, the of stormwater management facility.
Yeah,
So if we bring it here, it brings the NOAA standard. If we need a county by county, we need to do what Solomon has already done.
yeah.
Okay?
So if you have another project which you already set up, and when I use it, you can import it from
Yeah.
that project. So
Yep.
you don't have to type what I
Yeah.
just did here.
And then Arun's question is, remember the TR55, that SHA or MD manual, that table 2 point something that has a county wise different
Yeah.
P
Yeah.
rainfall for the different events.
Yeah.
So they updated recently. So his question is how to bring it.
Yeah.
Definitely is we need to type it for 1 year,
Yeah,
right? And then
lately,
2 year and 10 year.
lately, what we've been getting comments to use the NOAA C
Mhm.
rainfall intensity from NOAA website. So
Okay.
what we've been doing is downloading their
Yeah.
intensity chart
Yep.
and then entering those value into your 55.
And then this program automatically pulls those things.
it
We
does.
assigned those things there.
Okay.
So for simplicity, I just put the rainfall depths for 1 year and 10 year.
Yeah.
Or you can import it as we already said. The AMC, the moisture content is gonna stay standard, which is 2. So we are not gonna change that. So I'm gonna say apply. I think 1 and 10 year is enough for now.
Yeah.
Actually, we need 2 year also.
Yet
We need 2 year for
sediment control.
time of concentration.
Oh, okay.
Let me say 2. So now we have 3 rainfall events. 1 year is 2.5 and 2 year is, oh, I didn't save it, 3.1. Yes. And then 10 year, we have 4.6 for now. So I'm gonna say, okay. So now when I go to
Do you apply?
time of concentration, we said we're gonna, okay, for if you wanna put direct input, you can just use this and put the time you need there. And that's it, you are done with time of concentration if you wanna do it this way. But I'm gonna show you how to do it the way how we were doing it. So I'm gonna delete this. And then edit time of concentration, sheet flow. And then whatever the description you want here, I think we use AB here, right?
Yeah.
AB and the cover, short grass, 0.15, or if it is concrete, you can choose it also, but it is gonna give you the associated Manning's, number there. So the length will be, I'm gonna use a maximum 100, and we say that it is 3.1, sorry. And then here the slope, we said 0.02, which is 2%. And here I checked use common P2 so that it's gonna use for others for the shallow concentrated, or if we have pipe flow or others, it's gonna use this rainfall depths. So we have here 10 minutes, and I'm gonna add more shallow concentrated flow. Again, this is gonna be B, C. So is it paved or unpaved? I'm gonna do both. So for paved, it's gonna give you velocity factor, and then you're gonna put the length there and the slope 0.15. No, that's too much. 0.15, and then you have it here. So it is 0.3 minutes. That's too short, right? Let me check. So we have 1 minute there. Another one, I'm gonna add shallow concentrated. It's gonna be BCC, CD. So now we already used paved, so I'm gonna use unpaved now. So the velocity factor is 16.1. Based on that, it's gonna calculate, let's say it is 200 feet at 3%. So we have now a time of concentration. By the way, we can change the time of concentrations from minutes to hours. You do it in such a way that you come here to calculations. Actually, not calculation. You do it here in units. And then we are using English system. So for time of concentration, you're gonna look up the custom, and they're gonna find it here somewhere under custom, time of concentration. Here it is. So Here we have it in minutes. So if I want to change it in hours, I'm gonna type hours and the long name HOURS. And then of course you have to change here the scale factor that will determine, the value. So it's gonna be, how many seconds is that? 3,600. 1 hour is 3,600. That's how we change your unit for time of concentration from minutes to hours.
If we just leave it as minute, does it affect the results?
No, it doesn't. It doesn't. I mean, we were using here hours. That's why
Yeah.
I just mentioned it.
Okay.
But
Mhm.
so I'm gonna say okay. Yes.
No, it's a 60, not a 3. So
I'm sorry.
1 hour and 60 minutes, not 33,000.
Can you go back?
Oh, I didn't change it.
That's 60. Yep.
No, the-
He's right.
The factor, like if you go to the time concentration. Yep.
I think minute, you change second. So
one-
per minute,
Yeah.
60, right?
That's good. It is 1 second equal. I mean, 1 second equals 1/3,600 hours.
The
That is
second
the unit you're gonna use.
is second or minute?
Second. It uses a second. Second is a minimum and hour is a maximum. So that's how we convert. If you want to make it minutes, then it's gonna be 1/60 second. I mean, 1 second is 1/60 minutes. That's how we convert it. So this should be like this.
Okay.
Are we good, Jerry?
Yeah, yes. Yeah, okay,
Okay.
yeah.
Yeah,
I
because,
saw that 1
yeah,
second.
the
Yeah.
program is
Good.
picking a minimum scale of second automatically, therefore.
Yeah. So
Yeah,
we're gonna
okay.
see it here. So if I go back again, edit, time of concentration, you see, now it is in hours because I changed the units. It
Right.
was 10 something minutes, now it is in hours.
Can you show us how you enter like a channel and if it's a pipe flow?
Yeah.
Versus if it's a channel?
Yes. Yep, that's next.
So time of concentration, edit, no, new, it has to be new.
New pipe.
So it's gonna
Into the pipe.
be DE, right?
Yeah.
So here is pipe.
Yeah.
There's
I have a
channel.
question.
I'm
So for the
Yes,
concentration, the parameters for the minimum time of concentration
yes,
is
yes,
5
there is.
minutes, right?
It is 6 or 5 minutes. You can set it up. Let me show you how you set it up. That's somewhere. Here you set it up. You see minimum TC.
Okay, 0 hour.
So it is 0.1 hours, right? That's what
Yeah,
we
right.
use.
Okay.
Yeah.
Yeah, you set it up here, so it's gonna use that 0.1 hour.
The
Okay,
default.
then
So I'm gonna set it up here and
and then it'll
so-
automatically update it into
Yes.
that.
yes,
Okay.
yes.
Let's do channel first, then only pipe.
Oh, okay. So time of concentration. I'm gonna add, you said channel?
Yeah.
So channel flow. Again, cross-section area, you're gonna put here whatever you have. So I don't know, in square feet, what is a cross-section area we use?
Anything you can do.
1.5?
No, 4 foot by 1 foot is a 40 square. So you can say 60 square.
Okay, square feet?
Yeah.
Okay,
You are
perimeter.
doing a dummy example. So
Yes, so the perimeter is gonna be, let's say 2 feet.
4, 5, 6, 7, 8.
And then the,
For-
The
For
foot
I'm
is-
this
sorry.
one,
foot is way less.
for
What
this
did you say?
one, For this one, you can use the cross-sectional information from the channel and just use like hydraulic toolbox to figure out those numbers.
I don't understand.
No, I think, so what we need to do is your cross-sectional area means your channel, like it could be rectangle or trapezoidal or
Yeah.
ridge.
Yeah,
So you calculate area based on that section. And for the perimeter, if it's a triangle, it's just two sides, and if it's a rectangle, I mean.
The perimeter is a weighted perimeter. For example, if the channel is a 4 foot bottom and for example, 2 to 1 side slopes, then has a 1 foot of depth on it. So then we take a sloping sides and then the bottom of the
Okay.
channel.
Yeah, so
So that's how it automatically adjusts that for the weighted perimeter, even if we give a entire perimeter.
so
Yeah.
I'm gonna call it DE, and then for Manning's, of course, you're gonna look
That's
at here
for-
if it is concrete or,
For perimeter 4 is a little less. You can increase
okay, all right.
that one because
So what kind of,
7.
okay, what kind of surface we gonna use? Grass, let me find the grass channel. First. Here, right?
Yeah.
So I'm gonna use a middle value.
Yeah.
And then flow length, let's say it is 250. Is that too much?
That's fine.
And the slope, of course, here we're gonna put the slope, let's say 4%. We say the perimeter is gonna be 7, right? All right, so we have 0 hours. It
It's
is,
too short.
yeah, let me
So
say
increase that to ml
500.
feet and let's see.
Still. Is it too? Let me make it steep. How about that?
If you make it steep, then it would be more zero.
Yeah, you're right.
So make it a flatter.
Okay, it's still 0 showing for some reason.
Can you go back to?
You know what? Here I can change. Let me say, okay, I'm gonna go here under units again for time of concentration. I'm gonna change the decimal places to 3 because we are showing
that
it
may
in
help.
hours.
Yeah.
So let's see now. Here you go.
Yeah.
So it is 0.31, 031 hours. So the last one we said is a pipe, right?
Pipe.
It's the same, right? You give the cross-section.
Yeah, something, yeah.
Yeah, if it is the same, then let's save time.
Okay, so we are done with the time of concentration. We have 0.3234 hours. So now I have the rainfall depths, I have the time of concentration. If I double click on that, it's gonna generate me the hydrograph. So this is for 10-year rainfall, which is 4.6 inch. We just assume it's gonna be 4.6. The runoff area is our 5.2 acres. Runoff area. Runoff volume is this, and runoff depth is that's the Q 1.51, and the flow length is based on what we put on our time of concentration, 950 feet.
Yeah.
And the time of concentration is 0.34 hours, and the weighted curve number is 69. So that generates 8.29 CFS for 10 year. Or you can choose also here to see whatever you put. You can check here, the land cover, what we put, the weighted, and then how much of that total 5.2 acre is pervious and how much percent is impervious. And here you have the list of your time of concentration. Okay, so let me show you something else on the hydrograph. You can turn it on like 2D or 3D here. or you can also make a table view of that. For that, you see the runoff. The peak is between, here it is showing two bold values.
Yeah.
That means
yeah,
the peak is, it's not
Occurring
this, it's
here.
not this occurring here.
in between.
So to see that, you just come here and unshrink the table. When you unshrink it, you're gonna see the true. Here it is, 8.23. It is happening at 12.25 hours. It is, but it is now, the calculation is made every 0.05 hours. But if you want to change it, you're gonna come here at setting, calculations, and then here you're gonna have time span. I have the starting time 5 hours. I can make it 0 to cover the entire rainfall, And then here the increment, you can make it more or you can make it lower. So for now we have 0.05 hours. That will generate 481 points. If I change this one into 0.2, it is 1201 points on the hydrograph. So I'm gonna keep it there at 5, but I changed the time span. And here the unit hydrograph, SCS, of course, that's what we use. These are others. And what's the time span? I said rainfall, we have general. So I'm gonna go back to the hydrograph here. So I showed you the table. You can shrink it to make it smaller, but you are not gonna see the true maximum discharge. You have to unshrink it. So you sometimes you have here message which you can use to correct whatever error you occurs. Here it says longer time span is needed. I have 24 hours, so it says it's not covering the entire. So we can make it longer time span here. Let's make it 48, why not? So let's see if that message disappears. Green means okay, so that yellow disappears. But if it is red, then it is a problem. That means we need to fix it. So we have 3 colors of message. Green, which is okay. Yellow is just a reminder, and red means you have to fix it. So, you know what I'm gonna do? We are
To save the time,
Yeah.
you can copy this one as a POI too.
I can continue on this one.
Yeah,
Let's say this is now what I showed was existing.
yeah.
I gonna copy.
You can copy and paste as a POI too.
Yes.
And combine those two using arrow.
Yeah.
That would
Reach, can we introduce a reach? Like, let's say
You-
this is a sub drainage area.
Yeah.
Yeah.
And,
Yeah.
Like introduce a reach to connect these.
Yeah, that's what we are doing. For the reach, we need to
So,
copy area, so we
yeah.
have copied it to save the time.
So I just copied it. I have now 2 identical areas. I'm not gonna change we don't have time to change the units. So if I wanna see the results for both, let's say this is existing and this is maybe for proposed, I'm gonna make it proposed and I'm gonna edit only the impervious area. I'm gonna increase there. So let's say the impervious area went up by 0.5, so I'm gonna make it 1.7. So the grass will be 3. So the same drainage area, I'm trying to make the same drainage area, but I increased the, the same drainage area, but increase the impervious area. So now our weighted curve number is 73 instead of 61. So what it generates, let's see comparison. I'm gonna select both. Come. And then here you have comparison. You see? Here you can see the green one here in the legend is subconstant POI1, which means for our purpose it is existing condition, and the red one is proposed condition, which is so we went up from 8.29 to 9.94 CFS. So I'm gonna show you something here, how to design a pond. So I'm gonna drag and a pond here. And then I'm gonna link it. The way how you link, nodes are that you just drag.
I just like to mention one thing.
Mhm.
Solomon did copied the same sub area to show a comparison of existing and proposed condition. But what he is doing right now, he is using this to solve area, either existing condition or proposed condition, to train into a structure with the reach. So the purpose of showing before was comparing existing proposed. Now the purpose is how to route these areas under either existing or proposed condition into a structure. Okay.
So I called it POI1 proposed. So we saw that discharge increased. So here I have a pond. It doesn't have any value. Anything entered in. Yes, but if I right click and here it shows me the inflow is 9.94 and the outflow is also of course 9.94 because I didn't put yet the storage for that pond, and I didn't design any outflow. So for now it's gonna show me the same inflow and outflow. But if you click here on the sizing, you're gonna see this graph which shows you the discharge and required storage. We know that, how much was that? We know that it is about 8 CFS for existing condition, right?
Yeah.
So if you want to design that pond, you have a clue here that you go from here you're going to find on the discharge graph 8 CFS, which is existing condition. You're going to come across and then you go down, which shows us we need storage between 0.01, 0 storage,
Right.
for that pond
Mhm.
to make it 8, the discharge to control it to be 8 CFS
Yeah,
instead of
that's
9.
a good point. Yep.
All right, so, and then here I have events. Now it's showing 10 year because I chose here 10 year. But if you want to see the entire rainfall data which you have, you can click here update, and it's gonna show you 1 year, 2 year, 10 years. That's what we put in the rainfall depth. So it's gonna show you the inflow and the outflow. Of course, they are the same because, as I said, we didn't put any storage in that pond yet. So let's design some pond here. So here I'm gonna edit it. Here you have an option: none, catch basin, or detention pond. The catch basin is just like a manhole or some diversion structure which doesn't have any storage. So for me, I'm gonna use detention pond because I want that pond to have a storage. So for storage, you're gonna come here. Okay, by the way, if I choose catch basin, there is no storage here. It's gonna be just outlets and tailwater and other informations.
Yeah.
It doesn't have storage like a manhole or something. But this, when I choose the detention pond, it shows me now storage.
Yeah.
Now,
Yes.
Can we design a flow splitter?
Yeah, I'm gonna show you. Yeah.
Yeah.
Is it considered Yes, please.
Yes.
Okay.
Yeah. So I'm gonna work on the, if time allows. I'm gonna-
Yeah.
So I'm gonna go
Yeah,
very
don't-
fast now.
No, Dr. Ross, what I suggest, this is a very important tool. So let's go to the normal, clear spacing. If needed, we'll do the another presentation.
Okay. Okay, so for storage, I'm gonna put very quickly custom storage, like what we do here, surface area. Here you can turn on large units and on and off, which means if I turn it off, what I put here is gonna be feet and square feet. You see here? So elevation, let's say 102, area 1,000 square feet. 103, 1,200. 104, 1,300. I don't want to go to 6 feet because I'm gonna be caught with damn safety issue. So I'm gonna keep it 3 feet high. So we have now, I put here storage, like contour area at what elevation, like what how we do it. If I turn on here, a large unit is gonna show me in acres, the areas. The elevation is gonna stay at feet, but the area, the area is gonna be in square feet. It was in square feet what I put, but it can convert it to for us into a larger unit, but it's not gonna affect the storage. So we have storage now. And then I'm gonna design outlet here. I'm gonna start with culvert because that is the very first thing you're gonna put the downstream in the culvert. Here you're gonna put the invert, whatever you want. So the outlet invert, let's say it is 100, and the length of that culvert is gonna be 40. Now you're gonna see it's gonna calculate for you the slope here. If I change the length to 100, look, it is updating the slope. So you don't have to worry about the slope. It is gonna be a round shape and the diameter in inch is gonna be, let's say 12 inch or 18 inch pipe. And then I'm gonna go a little bit quicker to show you how it works. So here I choose a culvert and it's gonna be primary because that's gonna be our riser. It's gonna come out from the riser.
The principal spillway.
Like something like that, yes. So I'm gonna say okay. And here the entrance, because it is culvert, I'm gonna say square inch. So it's gonna give me, you see, again the KE, the
Yeah,
entrance loss
yes.
value. So I'm gonna say okay. Now I'm gonna do the orifices and wears. So
Low flow orifice.
yes, so it's gonna be here orifice or grate. So I'm gonna define it at, let me see, 102, 102.3. Discharge multiplier means if you have more than one orifice. If I make it 2, it's gonna show me 2. So it's gonna be, you have a choice also here, whether it is a horizontal or vertical. We are having it on a riser, so it's gonna be on vertical surface. And the diameter of that orifice is gonna be, let me see, 6 inch. And then the orifice discharge coefficient is here. What I need here, that's it. And then here, the routing, it's if you make it primary, so it's gonna be independent, but we want it to be routed to the riser. So I'm gonna say here, route it to device 1. Then I'm gonna say, okay. So here you see, we have the culvert. and we have the orifice. That orifice is going to be routed to device 1. In this case, device 1 is, here is a number. In our case, device 1 is the culvert. So if you want to add more, let's see some weirs. We're going to put for the weir. I'm going to use 104. We have 104 elevation. Yeah. And then the weir coefficient is here. And then it's gonna be routed to device 1 again. And then I'm gonna say, okay, hold on. I need to choose what kind of weir I have.
Okay.
So I'm rushing a little bit. So it is a broad crusted weir. It's gonna be here. The crust length will be, let's say, 2.5 feet or 3 feet. Side round, we don't have crust. Breads is gonna be, if you leave it, it's gonna assume it is sharp crusted.
Yeah.
So now I'm gonna put 1.5 feet breads, and it's gonna calculate give you the head and the associated C factor.
Yeah.
It's gonna calculate for you.
So if the building structure, your red is the thickness of the wall.
Yes.
Yep. Yes.
So again, the discharge multiplier, I'm gonna make it 2 here. So that
It's on two
on the
sides.
other side, yes. So
This is, I think, typical type K inlet. When you have.
no,
opening-
it is opening on the,
For the weir, like you're using two, so if it's a typical type K inlet with opening on both sides, you would use two here, but if it's only on one side,
Yeah.
you would use more.
one.
Yes. Yeah.
So again, don't forget that you are routing it to that culvert. So I'm gonna change from primary. If it is primary, it's gonna be by itself, but we want it to be routed to device 1. So now we have the culvert, we have the orifices, and maybe I'm gonna change this elevation 103, and then say okay. Now, if I double click, you see the effect of our pond is seen here. The inflow is 9.94, and then the outflow is 9.21. So we are attenuating something, but of course we need to.
Yeah. And can you show the report, how to create a report?
Yes.
Because this is good, because we compared existing proposed
So-
the pond also.
Yeah.
Now we need to know how to create a report.
So we're gonna print here report. So you can have an option of selecting which rainfall you want to use. You want to report for. So you can have either selected events, or 1 year only, or 1 and 2, or 1 and 3. If you just want to go with everything, you just select all. And then which nodes you want to report for. All nodes we want, right?
Yeah.
So here you have a choice, but I'm gonna leave it here, and then I'm gonna say print, and then I'm gonna save it as PDF. I'm gonna put it on desktop.
And give a name.
It's okay. To save time. So we are green here. That means no problem. And here is our report.
Yeah.
So this was the existing condition. I have to create a different file for existing, proposed, of course, but here I just put them together for now. So here are the reports. We have about 27 page of a report. So that's how you generate reports. This is subcatchment.
Right. And this report gives elevation and also gives the outflow, inflow, discharges, and
Yeah.
elevations. All information that we get from TR20,
Yeah.
they are
See.
built in here.
You see the pond information I put is here. Maybe I'm gonna make it.
Yeah, single page.
Yeah.
Okay,
Yes.
so this is David. I have a question
Go ahead.
regarding the weir and so when you put in like for device one, you say it's a riser, correct? So do we have to put another like on to represent the riser structure, or does it automatically recognize like a riser structure in it? Because there's no storage in
Oh,
it.
So remember the riser great.
yes, I can add it there. I didn't add it there, but you can add the
edit as a opening.
yes as opening. Let me show you how to do that.
Yeah, just a riser has an opening like
Yes,
pipe
yes.
goes from there.
So I'm gonna go again to the
Yeah.
pond, edit, and then outlets. Here I'm gonna add weir again. Where is it here?
Yeah,
Weir
that
or orifice, and then hold on.
so Dave, to answer your question, that riser opening gets built in into the program as either weir or orifice.
Here it is. You have now the opening as a horizontal now.
Yes, horizontal opening
Yeah, and I'm gonna put the elevation at 1.5.
and size.
And then, of course, if it is round or if it is uh, rectangular, you're gonna put yes.
Like the width could be like the opening of the riser, correct?
Yes.
Yeah, on the top. Here you choose,
Yeah,
when you choose
horizontal great.
So I think the width has to be your inside opening.
Yeah,
yes.
inside. Length and width and length need to be inside opening of the riser. So that would be horizontal plugged in as a horizontal here. The other pipe we will give a elevation different as a principal spillway, and then the program automatically integrates those two things on its own.
So I think, David, so when you're routing a storm to a microbiome, which typically doesn't have an orifice, I think only
The horizontal is
you
gonna
need
be
this horizontal
yes,
weir.
and the top elevation is the rim elevation. Yeah.
Yeah,
How do we
microbiome.
determine whether it's, you said it's broad crescent weird? How do we know that? Just based off?
Yeah, depends on which type of weir we are using.
Like it's a.
So yeah, if we read the weir types, there are already defined types of weir. If you have a smooth core,
Sharp,
that
broad, sharp
and then
crested,
sharp
yes.
crested,
Yeah.
there are different types. Which
So this is just arbitrarily, just
Yeah.
pick one, just.
yeah, this is just a dummy thing.
Yeah.
We picked up for an example. I
Yeah,
think, but for the specific project, there would be a specific type and
How you
Okay.
design it, how you
Right.
design it, and you're gonna put it here.
So
Yeah.
I think we still have a few minutes, so.
Yeah, let's go ahead and ask questions because we have
I just want to
6
show.
minutes.
I just want to show very quickly,
What
if I
question?
can, the
Okay.
the. I just want to show the. I didn't put the dimension. The diversion. So let me see. Let's say this is the drainage area I want to divert runoff from. So I'm gonna how I do it is I'm gonna bring another pond to it and link it, and then I'm gonna say it is a catch basin. So no storage, and then the outfalls will be designed. Let me.
So you're.
Yes.
Flow split.
Yes.
Flow
I have it set. I have set it up somewhere. Can I? I just want to show you the sketch here, which I drew. So
Okay.
this is a catch basin. 15-inch pipe is gonna bring the inflow. And we have a weir here. So the water quality volume or whatever you wanna divert through the
To the
orifice
facility.
to the facility is gonna go this way. And the leftover is gonna overtap whatever height you set up here and then go away. So that's what I'm gonna show you how to design it in HydroCAD. So based on weir, you can calculate the discharge. Maybe we can discuss on another day how to change the water quality volume. into discharge.
Let's do this. What I suggest, this is very important for us. This comes in every project because every facility need to be designed offline. So we are trying to show the offline. I think another session would be best for this. I request you spend this couple of minutes to answer the questions of this session.
Okay.
And we will hold another session for this specific flow splitter design.
Okay.
Okay.
Good.
So go ahead, ask questions. If you have any question, please ask the question. Okay.
So, let's say we have an outfall that has two sub drainage areas.
Mhm.
So there's one let's say sub drainage area A, and that goes through a channel, and then there's a sub drainage area B, which outfalls directly to the outfall. So
Okay.
how do we show that in that?
Yeah.
You mean you're gonna need a reach for that, maybe?
Yeah. And then draw the arrow from there.
So this one's gonna come. Oh, too close.
There.
So it's gonna come to this reach, and you wanna split it. You said.
No, so there's another drainage area.
Oh, okay. I can link this
Yeah.
to
So
it.
you can just link like.
And then from here to here. Is that what you mean?
Yeah.
Yeah, you can add how
But
many?
I mean,
Yeah,
the
yeah.
second one goes directly to the outfall, not to the reach.
You can
You
put
you can like this.
Yeah, initially I was thinking Solomon will combine these two into a one pond, but the things went other way. There is an option you can pull that arrow directly to the outfall.
Yeah.
Since it does not go to the catch basin or pond. So just it's a matter of pulling the arrow from that little round.
You can use this link, if there is nothing, you can just use a link
Yeah.
and then you can define this as none,
Yeah, this is a nothing just to
Yeah.
connect
Yeah,
the area in case
Use
you need
only.
to handle multiple things.
I can call it outfall. I mean outlet, if we call it, right?
Yeah.
And that's it.
Okay.
It doesn't have any data, but it helps me to link,
Yeah.
subcatchments.
So
To the outlet.
it looks like all the modeling, we can do it in one file.
Yeah.
Like all the even pre and post condition.
Yeah, but when you generate
report.
the report, it's gonna
It would be messed.
Messed
So it's suggested to do a separate.
Yeah.
We don't want the report
But-
mixed.
Like, yeah, if all the existing drainage area can be within one existing file.
Yes.
All the
Yeah.
proposed-
Yep. All POIs, 10 POIs coming to with all the arrows. Some goes to the pond, some directly outfalls, some goes to the catch basin. That can be done like this in one file for existing, all and other for proposed, only two files.
Okay,
We don't need TR55. We don't need anything. Everything is done here.
here we have a limitation, 20 knots. So if I have more than 20 knots, I can't save that file.
Yeah.
You see that?
Yeah.
1, 2, 3, 4, 5, 6.
Yeah, there is a
I have already
limitation.
7 here.
Yeah,
So-
there is this is a good point. There is a limitation. If we go more than 20 nodes, we need to request an increase in nodes
Yeah.
to the company, paying little more. That's a funny thing. Everything is business. So, but I think 20 is better for now.
Yeah.
Say we have more than 20, but can we just divide that into separate?
Yeah, yeah. Yeah.
So
Two separate file
how are
and-
you gonna link it,
Yeah, if it's not, it doesn't require linking.
Oh, yeah.
Yep.
Of course.
If it is not required linking, that's good. We can do it. Any question?
I have another question. So for that leash there, can that leash be like a weir wall or something?
You see here, you have a choice. It can be a pipe, a parabolic, a custom. You can design it, you know. You can
So a beach can be.
Zero.
Like a channel pipe or a stream.
Yeah.
Can be even a pond.
Right.
yeah. So I'm defining here the reach very quickly. Offset 2 feet. It's gonna be 101. You see, it is drawing for you. Offsets 3. So I'm gonna going to 100, and then 4 feet flat bottom, which is gonna be 100 again. You see? And then
Yep, it draws for you
yeah,
there.
and then after 4 comes 6, maybe. I'm gonna go up. Something like that. You're gonna define it.
Yeah.
And then
And that could be like the weir, like a weir wall, and then you just change the manning
Yeah,
to like be a concrete.
So that's what Solomon is
so-
currently drawing is like a section of a channel.
yeah,
So let's say you have a channel that has a variable section.
yeah,
You can probably, I'm not sure, you can probably define.
Yeah.
To the.
yeah,
to
because of
Yeah,
with the station and offset. So
uh,
0 station, 0 depth, one station, 0.5 depth. That's how we give a coordinate.
you can combine. You
X
can
and Y
combine
coordinate.
a rectangular, you know, in emergency spillway, you can cut a V notch, you know, for
Yeah.
example, in the bottom. So you can combine that.
Yes.
There are options. So this is, you know, example how you, you know, define your cross section of the reach, and then the other value will be the length and the profile.
Right. And then if you guys have any question, definitely it is a good starting, but there will be a lot of questions. Please email the questions to either Solomon or myself. Any questions? Next session we will put together for the flow splitter and or any efficient
There
things.
is an option also for dam safety,
Yes.
breach, no breach.
Okay,
dam setup.
that we will cover in that session.
Okay.
I think
Okay.
what we need to do, one would be a culvert design, because that comes a lot.
Yeah, color
Okay.
design.
And
Okay.
a flow splitter and that's it.
Yeah, and it's very hard to cover everything in one session.
So
We don't want to spoil your working time. So last question, if you have any question, please go ahead and ask, then we will wrap it.
can expect it's gonna go that fast. Short.
Okay, so let's say for example, right? What if you have like okay, it's gonna be a little bit complicated, but what if you had example? What if you have like one pond, right? The pipe, the pond, the POR right go to one pond, and that outfall is like a weir, is like a rectangle weir, and then that rectangle weir, right after that rectangle weir is another pond or like a microvalve retention. So would you have to do like
If it,
Yes, go ahead.
are you talking about something like this? A
Yeah,
pond
yeah, like-
outfalling to another outfall,
Yeah.
another pond?
Yeah, yep.
Then you're gonna create here a tailwater effect, because this pond is gonna create tailwater condition for this,
Yeah,
yeah,
and that means it's gonna reduce. It's gonna affect the discharge here.
right.
So we
Right.
can set it up also.
And
that-
then
like
Dave
that.
is saying, can we put weir nodes on the 3P also? Yes. We can put
Okay.
outfall weir in that pond also, the way
Here?
we did it. Yeah,
Yeah, we can.
yep.
So Dave, that's a curious question. Like, where did you encounter this kind of setup?
Where did you?
Like, generally in a real life, where do you see this kind of setup? Like there is a rectangular notch and a pond downstream of that.
In a baffle, sometimes,
Yeah, baffle wall.
Oh,
Okay.
Okay, let's do this. Any question, please direct to Solomon or myself in an email or in person for this session. And we will hold another session for flow splitter, dam safety and culvert design, okay?
Okay.
Very good.
What's the
Thank you.
software license? The floating license or it just on computers, each computer?
Oh, no, this is a limited, I think 3-4 licenses. So we can share. There is one shared license. You need to contact Rick for that shared license. Definitely Solomon and myself, we have one license, but I really don't work on this. I can release one license to one of you people who will be really working on this. We'll work out on that. We have almost 3-4 licenses. Okay.
Good. Thanks.
Okay, thank you, everybody. Thank you for this session. We will hold another one next time. Thank you.
Sure.
thanks.
I'll be happy to share
Yeah.
what I know.